Ah. Can I look at your screen? Oh, that's good. What does it do? Oh, sweet. I was like, is that peel apples or what is it? Very cool. I have a soft spot for musical instruments. Welcome back, everybody. Let's see, it is 10 o'clock. A couple more people filing in here. I brought a couple of toys to play with. If anybody is interested, especially those of you who don't have touchscreen displays, are more than welcome to try. I brought two drawing pads here. One is a Huion. This is a really relatively inexpensive one that doesn't show you the image, but you can sketch. It's like a fancy trackpad, essentially. Please take it and play. And then I also brought a Wacom tablet, which is the more fancy version, which shows you the image. And that one's really also super easy to use. So if any of you feel like trying it out, you know, help yourselves. I've sanitized everything multiple times with Clorox and everything else that I can think of. UV light. All right, so let's see. There's still a couple people joining remotely. Let's remember where we are. I think last time we talked about, did a little tiny bit of CAD. I think I gave you a very quick overview of FEA, finite element analysis, and showed you some of the capabilities of CAD. What I'd like to do today, so maybe before I launch into that, let me just ask, is there anyone who has a drawing they care to share? Something in progress? Would you like to show yours? Are you on Zoom, perchance? Okay, so anybody else? Hey, is anybody who was on Zoom, do you happen to have a drawing you would care to share? Please? No? I don't see too many faces online yet. Y'all need to wake up.
I can share mine.
Okay, that'd be cool. Thanks, Kavya. By the way, we can barely hear the people who are online. I don't know what's going on with my speaker system here, but I'll try to figure that out. So I just want people to get an idea of what others are doing so that we can have a look. Okay, I made you a co-host, so you should be able to share.
Okay, it's opening.
Cool. Peter, I never see something on your music stand.
You know, all my music stuff is off on my shelf.
What point of a music stand with no music? By the way, there's also nothing on your walls. I feel like you ought to put something up there too. Any other comments for Peter? Okay. Sweet. Oh, yes, this is a brilliant object. You know why this is so brilliant? Because I remember the days of whiteout. I don't know if it even still exists. There was this little painty product that you would take out. And so this is really, really nice. It's a beautiful mechanism. That's really cool. I love the way Kavya used two colors, used white and used green. Damn, I feel like we ought to have a class on like industrial design or something. Some of you really got some skills here. This looks really, really amazing. So, so Kavya, I guess you just need to do a little bit of labeling, but otherwise, by the way, that's the best hand I've seen so far. That's really good.
Thanks.
What did you use to do it?
I just used an old paint tool size software I had on my tablet.
Cool, cool. All right, so any tools that you have at your disposal, any software, whatever you'd like to use, feel free. I really like that, the perspectives and so forth. It really shows off the design really well. I think this is, this to me looks a bit like a storyboard. Like if you were gonna go in front of a company and say, hey, if we make these, we're gonna, you know, or go on Shark Tank or something like that. That works really well. Any comments? Intimidating for some of you, maybe? So we've got some real artistic talent here and really good seeing. Excellent. Anybody else have something to show? You want to show? This one is a musical object. Let me find you on the screen. Ah, where are you? Remind me of your name. There you are. I love the last name, by the way. Do you know the origin of it? So Funk, it sounds like funk, you know. Funk in German, usually associated with radio. So you'll see a lot of Rundfunk and all kinds of other kinds of funk in German. Sweet. I thought this was an apple peeler when I looked at it really quick, but then she explained what it is. That's cool.
So the button pushes down and it pulls a string which twists open which twists the tubing closed, so it has to pass through other tubing.
I sense STS assignment in this. This has got like the perfect. What are they wanted like 3 things in a chain reaction. This is perfect. Yeah. I guess my only question would be, where the heck is this in the instrument?
It's I don't have a picture yet, but it's in the front part.
Okay, so like the French. So it has this wrappy thing. Yeah. So there's this wrappy thing, and it's kind of in the middle of that wrapped around tube object. That's cool. Yeah, unfortunately, you have to unshare the other thing and then share that. Yeah, cool. Could probably do an entire class on the acoustics of the French horn. Is it heavy?
It's not very heavy. It depends. I use the saxophone, so it's not heavy, but it's really awkward to hold. Oh. It's right. The valves are right.
There's a lot of plumbing in there. I see.
The buttons are right there, and
wow.
The underside of the valve.
I wonder what the total length of it is. Like a set of intestines, almost. It's like really, really long. It's probably like 20 feet long or something. That's really cool. Awesome. Very interesting. Okay, cool. So I think drawings are coming along. The drawings are not due until when I make it next Tuesday or so. As you will discover, my due dates are kind of flexible. If just kind of play it by ear and see how you all are doing. If you need more time, fine. This is not most of my class. The spirit of it is to get things done, not necessarily to worry about schedule and so forth. The only thing you really need to worry about in this class in terms of schedule, really worry about is, of course, the lab assignments, because Professor Reimers is a little bit of a stickler about that. By the way, how is the lab coming along? Is it okay? Not too bad. Just let me know if you feel like if you have any comments about workload or difficulty of the assignment or whatever, or access to TAs, and I can probably help out with that. Okay, so what I'd like to do now is shift gears. I think last time we started talking a little bit about FEA. I gave you a quick demo. I think I wielded a tuning fork. Is that right? And I showed you how that works. What I'd like to do today is to pull up Autodesk Inventor. And how many of you are using Fusion, by the way? Fusion 360? 1, 2, 3, 4, maybe 3 or 4 in here, including online. What I'll probably do, I think what I'll do to help you out, you're going to find out that it's very similar. But what I'll do is I'll make a video, and maybe we can have a separate session or whatever, and I can give you a couple of tips on Fusion. I'll try to remember the differences between Inventor and Fusion as we go. I use Fusion. I have a Mac here on my, that's the laptop that I carry around as a Mac. I've also got a Windows box that I carry around as well. And I use Fusion on the Mac. I tried installing Inventor on the Mac, and it just consumed all my hard drive, so I didn't worry about that anymore. All right, so what I'm going to do is, let me switch gears here. What I'm going to do, decide how I'm going to do this. I think I will have Keith too, who's logged to share his screen. Yes. Why doesn't Keith too share his screen? And that way, it will appear on everybody's screen. Okay, this is weird. Okay, so does everybody see an Inventor screen, just a plain Inventor screen? I think you should. And if you have any questions, just holler as we go. By the way, is my audio okay? Are you able, everybody online, are you able to hear me? Good.
Yeah.
Okay, so what I wanted to show you today is I want to give you a couple of ideas for our next major assignment. And this is an individual assignment. This one is on making class rings. And so the idea here is to explore all the features of CAD using, simply by designing your own class ring. why do I use class rings as a CAD 3D printing exercise? Because first of all, it's a small object, so we can make them by the truckload, right? So if you screw up, we can make another one, no big deal. It doesn't take long. It only takes about 20 minutes to an hour to print most of your class rings. It's something we can print out on the 3D printers back there, and we've got fancier 3D printers across the way here. So we can get good results pretty quickly. Another reason is just that it forces you to confront a couple of basic CAD problems like scale. You got to make a ring that fits on your finger or your toe or your nose or your ear, wherever you're going to put your ring. So you got to have some sense of scale, and you got to be able to deal with the scale. So I think that's a really good lesson for CAD. One of the most basic things is just to control the scale. It also will demonstrate some features that are difficult to render in 3D printing. So like really, really fine text. In years past, I don't know if Kyle's year did this, but somebody made the One Ring, you know, from Lord of the Rings. It had the really complicated lettering around it. And we ultimately decided it's possible, but it's like really, really hard to get that fine detail in 3D printing. So, you know, lesson learned. I think that's a really good lesson to learn. What I'm gonna do right now is just take you from absolute scratch in Inventor and introduce some of the features of Inventor and just throw out a couple of basic ring design ideas, okay? And I'm recording this so you can go back and you can look and you can play around and you can make whatever you like, right? Probably this thing won't be due for another till like week after next-ish. I don't know, we'll see. We'll just see how long it takes. And then what we'll do after this is, what will we do after this? We will do 3D printing, of course. I'll talk about all the intricacies of 3D printing, and then we'll be pretty much done with this whole design, CAD, 3D printing, everything kind of stuff. That'll bring us into like almost midterm, right? And right around midterm is when we turn a corner and start doing some other group exercises and other kinds of stuff, okay? Where this is ultimately heading, I want you to be pretty good at CAD because ultimately we're gonna make, those of you who are here in person are probably gonna make these cigar box violins. I just throw a cigar box at you and some strings and a neck, and off you go. Those of you at home, because this involves a little bit of woodwork and you may not have those tools, I also have another option that I can send you a relatively easy to assemble slide guitar kit. I did that over the summer with a group that was completely online, and we had all kinds of fun. So we'll make musical instruments, and you're going to be able to use the CAD tools like FEA to simulate the sound of your instrument even before you made it, right? And be able to get all kinds of really cool stuff. That'll be sort of our crowning project. Kyle went through that entire thing. How long did it take? 3 or 4 weeks. Okay. Alrighty, so let me dive into CAD here, and please interrupt me if there's anything that isn't clear, if you have any questions. I think I'm gonna avail myself of a seat because I haven't had enough coffee yet. I need somebody to sit on. Okay, so let's get started. So this is what the basic, when you open Inventor, it'll probably the very first screen, splash screen would be something like, do you want to start working, or do you want to take a long, boring tutorial? And I always just click start working. So then I'm going to click part, or you could go here and do new part. That's fine. I'm just going to start the basic CAD design that we're making is called a part. And when that file gets saved, it's called a part file, .ipt, Inventor part file. If you look at lower left, a whole bunch of packages are loading. That's why it's taking a while. The first time, or when you log into Inventor, you're going to notice right off the bat that there's a whole lot going on here. This looks like the cockpit of a 747 or something. A whole bunch of buttons, right? So let me walk you through a couple of things. Down at lower left, you see XYZ. Those are the coordinates. There's a sugar cube object. That's what I call it. Up here that you're going to be able to rotate your design. And you see a whole bunch of three-dimensional tools. For example, extrude, revolve, sweep, loft, coil. I'm going to walk you through what each one of these things, well, not all of them, but what a lot of them do. Some of them are super intuitive. Here's a tip. If you remember nothing else out of what I have to say today, remember this. If you're looking for a tool and you don't see it up here, chances are you're in the wrong number of dimensions. So you can work in 2-dimensional space in CAD, or you can work in 3-dimensional space. Almost all of us feel a lot more intuitive in 2D, right? Using tools, regular drawing tools, such as you've already seen, or it might feel a little bit like sketching in PowerPoint or something. So the very, very first thing that we're going to do, almost always in almost any CAD design, is click Start 2D Sketch. And that immediately confronts us with some options here. we have the XZ plane, we have, what is this? YZ plane, I can barely see the color, and XY plane. It's Wednesday, let's go with the XZ plane. Oh no, we went with the XZ plane line. I'll go the XY plane. There we go. Notice that the tools up top immediately changed. Now we're in 2D land. So just remember, I mean, almost every confusion that people have getting started has to do with not realizing which realm you're in. So let's make the most idiotic possible ring. What I'm going to do is I'm going to select the circle tool, and for some reason I'm working in inches. I don't know, I just set it up that way. And let's make a circle that is an inch. So my finger, I think it's like 0.76 or something around the knuckle here, inches. So I got to make my ring big enough to fit. I'm going to make a hole inside this, so this needs to be even bigger. So I'm going to make it 1 inch. There's a 1 inch circle, and now that's pretty much it. I can finish this sketch, and now I'm back. Notice that the 3D tools came back. So now I can click here, and I can just extrude. Not that far, please. Let's go 0.4 inches, say, something like that, right? Looks like a little puck, a 1 inch puck. Notice what I'm doing here is I'm rotating, I'm dragging on my sugar cube to rotate the design. And there's also a hand tool over here that you can use to move things around like that. I think I mentioned if you're going to become a serious CAD practitioner, I would highly recommend availing yourself of a 3-button mouse. And if you have a 3-button mouse, where do I have one? Oh, I didn't bring it with me. Well, I've got one down here on my desk on the lectern that I can't show you. There's a little rotating wheel thing, and that thing is super handy because you can scale just by rotating that. The CAD software, all the CAD software we use was built for 3-button mice, pretty much. It's hard to CAD on a touch screen. It can be done, and I've done it, but it's like, you're probably going to want to, if you're going to go into Civil or Air or Mac, you're probably going to want to get yourself a cheap a gaming mouse or something like that. All right, we got a problem with this ring. I can't put my finger in it. Okay, so let's drop a hole. Yes, there's a hole tool. Boom. Okay, that hole looks a little bit big for my finger. I can change the size of this hole. I can do it here or I can do it here. I think I said that my finger size was like 0.76 inches, something like that. Okay, there we go. There's a ring. Exciting. End of assignment, right? Done. No, you have to personalize it in some way. How are we going to personalize this? What would you recommend that I do to this ring? What would be exciting to do? What would be interesting? What should I put on the ring? I should probably put some text. What I'm awkwardly trying to do here, my mouse has gotten stuck. If you look at lower left of the screen, you see the XYZ coordinates, and I'm just rotating so that I've got the XY coordinates. So I've got it sort of in a conformation that I'm comfortable with. I'd like to add text to this. Notice on the left-hand side of your left-hand pane here, there is a bunch of stuff. And some of this stuff is super, super handy. So what I'm going to do is I'm going to click out Origin. There's a plus sign there, and you click it out. And then you have all kinds of handy planes that are there for your use. You also have some handy axes, and we'll come back to use those in just a minute. Okay, so I'm going to pick a handy plane. Let's pick the XZ plane. And I have a religion whereby whenever I add a feature to something, I put it in its own plane. I start off in its own plane. It gives it a place to be. It gives it a place for me to go and say, hey, I need to work on that thing in that plane. We're going to add text to this. Text, at least for starters, before we extrude it or emboss it, is just a 2-dimensional thing. The ring is already 3-dimensional. So we need to introduce a plane to put our 2-dimensional text in there, okay? So get in the habit of doing this. What I do is I start off with a plane, and I'm really big on making offsets. So I make an offset plane. Yes, I do. Oh, don't crash on me. It's gonna come, there it is. And there's 2 ways to make your offset. You can either fill in a number here. Let me just turn my ring around a bit so you can see what I'm looking at here. You see this arrow? You can just tug on the arrow and pull the offset outside the ring like that. It's about ½ an inch, okay? Pretty straightforward. Now, the beauty of this practice of using offset planes is that it gives you a named plane. It's called work plane 1. It gives you a named plane in which you can do other stuff. So what I'm going to do is I'm going to go into work plane 1, and I'm just going to start a 2D sketch in there. And now, lo and behold, all my 2D tools come back. All right, so now I can use text, and I can go like, tell me what text to put in here. It's is it Wednesday? I think it's Wednesday. Can't keep track of what day of the week it is. I'm gonna be curious if that fits on there. Let's just have a look. Oh, that's gonna be a close one. I don't know if that's gonna work. I made it so big. Let's try. I tell you what, I'm gonna chicken out a little bit. I'll make it a little bit smaller. And my objective here is to demonstrate what happens if the text runs off the ring. And by the way, there's a little quirk with the text size tool. You have to drag over the text in order to resize it. I know, it's kind of annoying. And I like things that are bold, and they will 3D print better. I just get in that. Okay, so there we go. So now I've got the text. Does anybody see a problem? The text runs off the ring. Okay, so that's a problem. It runs off the ring. How are we gonna? So now, do we want to emboss this? I guess let's emboss it into the ring. So what I'm gonna do is I'm gonna take this text and I'm gonna project it onto the ring. Okay, so I'm gonna use the emboss tool. Now let me draw your attention to, when you click the emboss tool, you need to then click on the text that you want to emboss, and let me draw your attention to the arrow here. You see the green arrow? That tells you the direction that you're embossing, and the green means you're adding material, red means you're taking material away. So obviously we want to have red and we want it to go into the face. I think these commands are pretty self-explanatory. See the red arrow pointing in? That tells us that, that the text is going to go into the ring. And then we click OK. Disaster. Create emboss feature failed. What happened? The text didn't have anywhere to go on the sides, right? It ran off the ring. Okay, so that sucks. So let's do it again. This time we're going to be a little bit smarter. What we're going to do is select the text, and we're going to do wrap to face, and we're going to select the face, and then we're going to emboss, make it red, and make it turn in like that, and go like that. Boom. Okay, so now we got something that wraps around the, okay? So very, very basic thing. By the way, I'm really big on creating planes, but I'm also really big on hiding them after I'm done with them. So what you can do is just right-click on the plane, make it green like that, it says Work Plane 1, and then you can click Visibility, and it's gone. Anything else you'd like to do to this ring? What else would you like to do? Rough crowd. Would you like to make the edges smoother? Yeah. Okay, so notice there's a fillet. I call it fillet. Some people call it fillet. And there's camphor. That's the way I pronounce it. So I'm going to fillet these edges here. So let's fillet the edges and make it more attractive. So what I'm going to do is click here. Ooh, that's a lot of fillet. You can change the amount of filleting by the radius of thingamajig, radius of curvature, like so. And you can select however many edges you want. Oh, that looks a little bit too big. Let's go 0.5, something like that. And then on the bottom as well. So you probably don't want rough edges on your ring. Okay, something like that. And there we go. Any other ideas, design ideas for this ring? What else would you like to have on this ring if it were your very own? Are you over this ring? Okay. I think we should make it out of gold. So what we can do is go to Tools, Material, and one gold or silver. What do you prefer? Gold. Ta-da. It's gold. If only we could 3D print this. That would be nice. Okay. So there you go. So there's one ring idea, very basic ring idea. Okay, pretty straightforward. Let me give you another ring idea. I'm just going to start another part file. Are any questions online? Oh, there's a chat. Yay, people are alive. Can you simulate putting a finger in it? No. No, I cannot. I will think about that. I will think about it. Actually, there is a way you can do that. What you could do is you can import a CAD model of a finger, and then you can make this part, you can make the finger one part, and you can make the ring another part, and then this could get pretty filthy pretty quickly. You can then use what's called assembly. In the assembly tool, you can move two parts relative to each other. Maybe we talk to that later. Okay, so let's go. I'm just going to start a new part here, standard part, and I'm going to create another part, and let's see if I can find something that wakes you up. Give me some ring ideas here. What would you like? Oh, years ago, we had a series of unfortunate events downtown. I think a student got mugged or something like that. It was really pretty scary. It's pretty rare that we have any kind of crime around Charlottesville, but anyway, that happened. And so I had a student at the time, and the student wanted to make brass knuckles. I thought that was awesome. So she made brass knuckles for this assignment, and it was just like a bunch of rings, and they had little spikes, and then you could make a donut ring, says Kavya. Okay, that's not hard. I can introduce a new tool with a donut. Kavya wants a donut ring, so I'm going to make a donut ring. So what we're going to learn how to use to make a donut ring is the Revolve tool. Okay, so what I'm going to do is I'll start another 2D sketch. I'll pick a plane to start in. And my idea here, look at the orientation there. My idea here is I'm going to place a circle thereabouts, something like that. What does a donut look like? It's kind of like that. Relative to the radius, the thickness is like a fifth or something like that. Something like that, okay? And I finish this sketch. Okay, and now I have to click out origin, and I'm gonna find myself an axis around which I can wrap this circle, okay, in order to make Kavya's, or bagel. Yeah, bagel sounds really good right now. So we're gonna find an axis. There's an axis. It looks like the x-axis is gonna work really well. I don't know how well you can see that on your screen, but there's a, oh, I can actually dim this just slightly. I think it a little bit more visible to you. Yeah. So you can see what my plan is here. So I'm going to click Revolve, and the first thing I'm going to do is select the profile, and then I'm going to select the axis, and just select. Yeah. As I'm clicking away here, there. Okay. So you see what happened? I selected the x-axis, and there we got the donut ring. Are you impressed? Bagel. Is that nice? When you click OK, then all the other stuff disappears and you're left with the donut ring. The donut ring has a little bit of a problem in that it's pretty hard to project text onto it. How would we project text onto this? Like, let's suppose we want to personalize this donut and we want to put some text on there. What I would recommend doing is as follows. You first of all select a plane that is convenient. So let's rotate this so that we've got something to look at here. And I'm going to select a transverse plane like that. And then what I think I will do is, yes, I will make an offset plane. And I'm going to pull my offset plane out. I'm going to leave it slightly buried. Let me rotate this so you can see what I'm doing. I'm going to leave the offset plane slightly buried inside the ring. You will see the wisdom of doing so. No. You will see the wisdom of doing this in just a sec. So what I'm going to do here is I'm going to leave it ever so slightly buried inside. Let's go with 0.6. A little bit more, 5.9. Yeah, something like that. And then what I'll do is I will, as you probably would have guessed, I will start another 2D sketch inside there. And then let's put some text inside here. So let's put, hey. This happens quite often that the text is rotated with respect to what you want. This is pretty straightforward. What you do is click the rotate tool, select the thing you want to rotate, and then select I just put a dot wherever you want your center of rotation. Click done, and then you can drag your hay there. So the hay is actually inside the ring. What's the point of that? You'll see in just a sec. And so now I can select, I can extrude my hay out of my ring. Oh, not that far. I don't want to extrude it that far. Let's go with 0.05. Even that looks like a little bit much. 0.4, something like that. Okay, and now we got a ring with hay coming out of it. Why did any ideas as to why I buried my offset plane inside the ring for this case? Any opinions?
So the text and the ring surface would already be like intersecting.
Okay, so the one idea that was online was that the two things would be intersecting, and I think I heard somebody say pretty much the same thing back here, so it'll be connected. Yeah, sort of, not really. Really the issue here is that this is a very complex surface. The donut is, let me get rid of this. Oops. Get rid of the plane. This is a very complex surface. Your donut there, your bagel, is actually curving in two different directions. And when you try to project text onto it, it's really hard for the program to figure out exactly how to project that. That's actually a really complicated thing to do. So what I did by burying the plane inside the ring is I gave it a well-defined two-dimensional place to start, okay? So it's a lot, you can project text onto a really curvy surface, but it's probably not gonna work very well. It's a little iffy, right? So in this method is guaranteed to work. The other method that I showed before, where you just sort of hover the text outside the surface and then project it, if it's a really complicated surface, it may not work very well. Okay, so that's a pretty standard trick for that. Since we made a donut ring, let's make something more complicated. Let's make, I had a student 3, 4, 5 years ago who demanded that I make for them a DNA ring. And I had to stew on that for a long time. They wanted a double helix going around their finger. And I had to really think, like, oh, how am I going to do this? It sounds like a really difficult CAD exercise. Let's see if we can do it. And what we're going to use for this, oops, I'm going to start a new file here, a new part file. What we're going to use, the tool we're going to use for this is the sweep tool. Now, sweep and loft will make you all powerful in CAD. Once you understand sweep and loft and how to use those, you can become an aerospace engineer, right? This is something that you use a lot in aero, because think about all the complex control surfaces of an airplane or a helicopter rotor or something like that. You need to take a block of material and you need to sweep out something that actually changes over length, right? It's actually a fairly complicated design. So, so once you understand those tools, and I'll just show you how to use sweep today. Sweep is really cool. It's like a jazzed up version of Revolve. So what we're gonna do here, I'll start again with a 2D sketch as usual. And then what I'm gonna do is I'm going to make, try to envision DNA looking down at, try to envision a cross section of DNA. You sort of see, two strands in with a double helix, right? So I'm gonna try to make something that looks, I could have done this with a symmetry tool, but apparently I'm too lazy to do that. Okay. So I don't know, one is slightly larger than the other. You see, I didn't make this exactly perfect, and that's actually a good thing to do the first time you try it. Just sort of see what happens if your circles are not exactly the same thing. So I'm gonna finish that sketch, and now I'm gonna do another sketch, and it's gonna be transverse. It's gonna be perpendicular to this plane. So I'm gonna pick a perpendicular plane there as YZ plane. You'll see why I'm doing this in a sec. And I'm going to start a 2D sketch there. And now I'm going to make another circle. And this one is going to be perpendicular to my first circle. All right. Does it look like DNA? Sure. What's the point of the circle with the bunny ears? What we're going to do is we're going to sweep these two circles around this other circle. So by defining this circle, we defined a trajectory around which you can sweep the other things, right? So, okay, so let's try it. So we do sweep, and the first thing I'm gonna hold down my shift key so that I can select two objects to sweep, and then I'm gonna select the profile. Right, there we go. Boom. Oh, I ruined my surprise. Hold on a second. Let me change the twist to 0. Okay. So if the twist is 0, it gave me a little warning about intersecting. I'll explain that in a second. But there you go. So you get a double donut. Not too exciting. Doesn't look a whole lot like DNA. Although, I mean, I guess if you dropped a bunch of lines vertical, that wouldn't be terrible. It could look more like train tracks or something like that. Let's back out of that and let's redo this. And now I'm going to show you one of the features of Sweep that makes it really, really cool. You select your path, and then you can add some sweep. So let's go with, I think I already did 720. Why should it be multiples of 360? I think you'll, little IQ exercise, you'll see why in a sec. If it isn't, then you get something that's kind of ugly. All right, there we go. Notice that it says some things don't intersect. That's if my symmetry wasn't perfect or something like that, then you can get some kind of rough edges. Because I didn't make my circles, I didn't align them perfectly. You notice that some of these things are not perfectly circular all the way through. Okay, so what you get is really, really cool here. You like? So this is, it kind of looks like the DNA double helix. There's a structural problem, and if we go in here and we poke around and rotate a little bit, do you see the two are not connected? So if we 3D print those, it'll stay interlocked, but they'll be kind of loose. So what's missing here from the DNA is the base pairs, right? The little connections between the two, between the double helix, between the helices. Okay, so how are we going to add those? This is pretty straightforward and fun to do. What you do is need to find a plane that cuts right through the middle. So let's find a plane. There it is. Looks like the YZ plane will do just fine. So I take the YZ plane. Notice that it's right smack dab in between the two because of the way I set this whole thing up. And I start another 2D sketch there. And then what I can do is I can just use common drawing tools and just draw some posts. So let me just draw one post here just to demonstrate the technique. I'm going to draw a post there, and I'm going to click Finish Sketch. And if you look carefully in here, you can see that I've got one post. See it? There it is. And it's hovering in between. It's a two-dimensional object still. So what I need to do is now I need to just extrude that. So let's extrude it. Yeah, that was a bad extrusion. I'm going to do a symmetric extrusion. So it extrudes in both directions like that. And we don't need an inch-long post. That's a bit much. I think we need 0.1 inches or something like that, right? And now I have constructed a support beam. Oh, I didn't go far enough, rats. I didn't go far enough. The whole day is ruined. How am I going to fix this? Notice that whenever, as we are working here, this pane over here gets populated with everything that you do. So if you screw up, you don't have to start from scratch. You can just edit things on the fly that you just did. And this extrusion, for example, we can edit this feature. And we can change how much we extrude. So I could change this to, there we go, fixed, boom. Okay, so the CAD software is really made to make your life pleasant. You can go back and you can change things and you can make things look as elaborate as you like. Cool. Now when I made the DNA ring, here's a little problem. So when I first made it, this is not a particularly great example. I'll see if I can find the original design where I spent a little bit more time. The base pairs have to go in different orientations. And so I had to go through and painstakingly add each single one. And then after I did all that, I realized that I could have just turned on symmetry for this whole thing. And so like if you can look at this and recognize that it has 8-fold symmetry or whatever fold symmetry, then you can identify that symmetry, and whatever you draw here will also go there and there and there and there and there. Yeah, you could save a huge amount of time, right? So when you become better, and the one thing about CAD is there's always 50 different ways to skin the cat. You can always, you can go in many different ways, and as you get a little bit of experience with it, you'll become more efficient. right? Any other designs you might like to make? I mentioned before I got sidetracked on the DNA, I mentioned that I had a student who made brass knuckles, and we got to talking about the brass knuckles, and the first thing is she wanted just to inflict pain, right? So she just had some spikes, and I'm gonna hit somebody with the spikes. And then we got the idea, we're like, well, it'd be nice if you leave an identifying feature on the person. So like if the police grab them later. So like if it said like UVA and like on the forehead, boom, you know, don't F with me, right? So, so then we decided it would be nice to make a stamp. So let me show you how to make a stamp. So let me start from scratch again. Yes, we start with a 2D sketch. Select a plane. And let's make something that has a, what I will do is I think I'll make a simple ring as I did before, and then I'm gonna show you how to extrude a plane from it and then put some text in there. Okay, so let's start off. Remember how this works. A simple ring is really, really simple, like that. Okay, finish that sketch. Now you're experts, you can make this thing really, really quickly. I'll make it like 0.4 inches as before, maybe 3.5. More petite. Okay, like that, and drop a hole in that. Let's try to center the hole a little bit better. There we go. And now I would like to make like a facet on it so that I can put some text. Some of you might want to put like a QR code or something like that, right? I mean, why not? So, so how are we going to do that? Any ideas? If you've learned nothing else today, you've learned that I'm really into making planes. So here we go. Let's make a plane. And we do an offset. Let's do an offset, and let's bury this offset inside the ring ever so slightly. Like, I don't know, like that. Maybe a little tiny bit further out. 385. Okay, so I'll go with something like that. And then I'm going to start a 2D sketch here inside this. And now I'm going to drop a, just drop a rectangle of some sort, right? It's not very attractive, but it'll work. Boom. And I finished that sketch. And now you can probably guess what I'm going to do next. I'm going to take this thing and I'm going to extrude it in that direction. So let's just extrude it, not too far. I think maybe 0.15 maybe would work. Yeah, something like that. Okay, voila. Now we have a ring. This is super handy. We've got a ring with a flat on it, and we can put whatever we want in the flat. You like? So what are we going to put in the flat? Any ideas? What should I put in here? Some text? I'll start with some text and then we'll get more elaborate. I'm really big on making offset planes, as you have probably gathered by now, even if the offset is 0. Because of why? Because it gives me a named plane that when I click on it, I see work plane 2 and it just makes me feel good, right? It has a well-defined place to be. I feel like Bob Ross now. Everything in your painting, everything wants a place to be. Don't you want a place to be? Don't you want your own plane? There, that should make you feel good. Right, so let's put some text. So I'm gonna put hey inside there. Let's do that. And if I want my stamp to be, if I want it to stamp hey, so tell me if this is gonna work, right? So let's suppose that now I extrude this out. I extrude hey out by like 0.05. Is this stamp going to work? What do you think? So if you dipped your ring in some ink and you stamped it, what are you going to get? You're not going to get hey, you're going to get the mirror of that, right? That's a problem. So we need to actually mirror the text that if you're making a stamp, you got to mirror it. So let's go backwards a couple steps here. Just one step. And what I'm gonna do, because I was so smart to put this thing inside its own plane, I can now take that plane and flip the normal of that plane. And I'm gonna have to do some rotating here. But anyway, you get the idea. And now it looks like Greek. Huh. Okay, so we got that. And then now we can extrude this thing. Notice that the extrusion is pointing in the wrong direction, so we need to flip it around like that. And now we have something that if you dip that in some ink and stamped it, you would actually get hay. Cool. Other kinds of cool things you might want to put on here. Anybody else have some designs or something else you might like to put on here? Do you want some, how about some, let's put some jewels on here. Let's put a diamond on here. They want a diamond on the ring. And the way I'm gonna do that, let's go like this. I can select a plane that's convenient to me. The plane is at the bottom, and I will make an offset plane from that, as always. I'm just gonna pull this up to about halfway. Let's see if I can make some impressive jewelry here. So what I'm gonna do is take this plane, and I'm gonna start a 2D sketch. You get kind of getting the pattern here. It's always the same thing. What does a diamond look like? It looks like a polygon, sort of. It's got like facets, right? So I don't know how many sides it's got. Anyway, let's pick a pentagon. I think that'll work. And what I'm gonna do is I'm just gonna, oops, I don't want to start from there. Okay, undo that. I want my polygon to go from like that, sort of. Does that look sort of like a diamond from the side? Something along those lines. Okay, so that's done. And now I've got myself an attractive, very valuable gemstone on there. And I'm just gonna extrude this thing. And I'll do a symmetric extrude. Notice that there's this option where you can pick symmetric and it extrudes in both directions. And then I can select whatever thickness of diamond I want, however many carats I'm after here. It looks like that's a little bit too big. How about like that? All right, does that look realistic or what? Let me get rid of the visibility of this thing. You people are not impressed. Man, rough crowd. I can do some more things to this to make it look more realistic. I can use a Camphor tool. So here's a Camphor tool over here, and what that does is instead of making smooth edges, it makes kind of facets. So I can come over here and I can facet this thing. I don't want to facet that much. Let's go with like 0.05, something like maybe a little bit more. Yeah? Oh yeah. Something like that. Oh yeah. Good? Not really, but you get the idea. So if you enjoy this kind of thing, you can play around and you can probably make it look more realistic. Let's see. I don't know how many facets you want here, but you can play around with it and make it look quite nice. Okay, any other design ideas? Anybody have any, anything you would like to make? Yeah?
How would you do text on the inside of the ring?
Oh, excellent question. So the question was, how would you do text on the inside of the ring? Just as before, you're gonna find some convenient plane like this. Whoops. There's the X, Y, Z plane, and I'm gonna start an offset, I'll start an offset plane, and I'm just gonna set 0 offset on that thing. And then what I'm going to do is I'm gonna take this and I'm gonna start a 2D sketch in there. Start the 2D sketch, and it looks kind of complicated right now, but just remember where your text is. And let's put inside. And then if we rotate the ring, we can see, oh, it looks like I need to rotate. I need to rotate my inside. So let's do this. I'll set a center of rotation. Whoa. Whoa. There we go. Okay, done. Got to move the ring around a little bit to make sure that the text is actually inside the ring like so. So now, whenever you look at it, you can see that the text is indeed on the inside of the thing. And now we want to like project it. You were thinking about maybe project it on the inside. So we could do, you finish the sketch and then go with, say, emboss. And let's have it wrapped to this face, to the interior face. Put it like that, 0.1 inches. Oh, I made it a little bit too. I kind of screwed up a little bit there, but you get the idea. Yeah? So the general technique is use your planes. Click out origin, use your planes, put your new text inside your plane, and then you can emboss it or extrude it or do whatever you want to do. Okay, so that's all we got time for today. I'd like for you to install your software if you haven't done it already and go ahead and get things running and play with it and see if you can start coming up with a ring design. I will post an assignment along these lines shortly. See ya. Take care.
Thank you.
Yeah.
Thank you.
See you later.
See you Friday.
See you. Take care.
Thank you.
You too.